everyone, it's Justin again. Welcome back. In our last lesson, we explored dot plots as a great way to visualize trends. And today, we're going to explore another type of visual representation in statistics. This is called a histogram. First, we'll explore the parts and functions of histograms, and then analyze and interpret them. Let's get into it. Does a histogram look familiar to you? What does this remind you of? A histogram looks similar to a bar graph, but are they the same thing? Pause now to jot down some differences you notice between histograms and bar graphs in your guided notes. Unlike the bars in bar graphs, the bars in histograms don't have gaps between them. The bars are touching in histograms. While bar graphs almost always have categories on their x-axis, histograms only deal with numerical data. You'll only ever see numbers on the axes of histograms. You might have also noticed that the bars of histograms are between numbers on the x-axis. For example, this bar is between 0 and 5, and this bar is between 35 and 40. This is different from bar graphs and dot plots where the bars or dots are directly above the category or number. Why do you think the bars of histograms span between numbers? Because histograms deal with intervals. Histograms use bars to show how many data points fall within each interval, which you know as frequency. These intervals are known as bins in histograms. Let's zoom in on these bins. Take a look at the first bin. What's the interval of the first bin? Maybe you said 0 to 5. How about the second bin? What's the interval there? You might have said 5 to 10. But notice that this includes 5 twice. Why might that be a problem? If we had a value of exactly 5, we wouldn't know which bin it'll go into because it overlaps both bins. Mathematicians realized this pretty quickly though, and the rule is the overlapping value between bins will always go to the higher bin. That said, which bin would the value of 5 belong to? The value of 5 would go to the bin on its right since that's the higher bin. That means that the first bin would not include 5. How can we make this less confusing? What could we change this 5 to make our intervals more clear? We might change this bin to 0 to 4 instead to avoid confusion. Which bin would a value of 10 belong to? The overlapping value always goes to the higher bin, so a value of 10 will belong in the bin on its right. Oh, that means we should change this 10 too. What should this bin interval be? The second bin is from 5 to 9. That would also mean we may need to change the 15 of this third bin to what? Yep, 14. What's the pattern we're seeing here? The overlapping values like 5 and 10 will always be included in their higher bins and excluded from their lower bins. Okay, let's zoom back out to look at the entire histogram. Let's take a look at the fifth bar of the histogram. What's the bin of this bar? The bin is 20 to 24 since the overlapping value of 25 is only included in the next bin. But 20 to 24 of what? What are we referring to here? Since those numbers are on the x-axis, that means this bin represents 20 to 24 text messages sent in a day. How tall is the bar? It's lined up with the 2 on the y-axis. But 2 of what exactly? Looking at the y-axis, this means the bar represents 2 students. So what are the bin and the bar telling us together? It's telling us that there are 2 students from the data who typically send 20 to 24 text messages a day. Let's get even more specific. What grade are these students in? Looking at the title, we know that these students are 6th graders. So 2 6th graders typically send 20 to 24 text messages a day. Now, I want you to try 3 questions on your own in the guided notes. What does the second bar of the histogram tell us? How many 6th graders typically send less than 20 text messages a day? And what can we infer about the texting habits of 6th graders? Pause now and resume once you're done. So, what does the second bar of the histogram tell us? What's the bin of this bar? It's 5 to 9. But 5 to 9 of what? 5 to 9 text messages sent in a day. How many 6th graders typically send 5 to 9 text messages a day? This bar lines up with 10, so this bar is telling us that 10 6th graders typically send 5 to 9 text messages in a day. For the next question, we need to figure out how many 6th graders typically send less than 20 text messages in a day. Since 20 is an overlapping value, which bin would exactly 20 messages belong in? 20 messages will go in the 5th bin, from 20 to 24. That said, which bins represent less than 20 text messages? The first 4 bins all represent less than 20 text messages, from 0 to 19. Now what do we need to do? Yeah, we need to add up the number of 6th graders in all 4 bars. Starting at the first bar, this is directly between 12 and 14 students. So how many students will that be? 13 students. The second bar represents 10 students. The third bar represents 5 students. And the fourth bar represents 3 students. In total, that gives us 31 students. What do the 31 students represent? 31 6th graders typically send less than 20 text messages in a day. Lastly, what can we infer about the texting habits of 6th graders? Inferences will vary, but let's look at some trends. Where is most of the data in the histogram? Most of the data is on the left side of the histogram. From this, what can we infer about the texting habits of 6th graders? A reasonable inference would be that most 6th graders send less than 20 text messages in a day. How about an inference that's slightly less reasonable? Inferences that guess at the reason why 6th graders may not text as much. Maybe we can say that most 6th graders don't use text messaging often and have other apps they communicate through. How about an inference that is very unreasonable? Maybe we can say that most 6th graders spend a lot of time on video games, and that's why they don't text as much. Great job working with histograms and interpreting them today. Soon enough, we'll be creating histograms ourselves from datasets. See you next time!